So we're going to learn about vectors, and we're going to see how we know, or what we know in trig, how that applies to vectors. A vector does two things. A vector describes a magnitude, which we are going to understand as a length, and a direction. A vector has magnitude or length and direction. So you'll see here is a vector. You'll know it's a vector because it's got a little arrow on the end, and it's got a length. It's got a length, so that is its magnitude. And then it's also got a direction. This vector is going this way, okay? So every vector has these two parts, a magnitude and a direction. We're going to look at two forms. We're going to look at the polar form and rectangular form. Polar form is going to be more alike, sort of like radians. It's going to have to deal with the radius of that circle. It's going to have to deal with the angle, the angle that we look at, and then rectangular form is going to be more like coordinates, more like we're used to dealing with before we knew anything about trig. Okay, so here we've got this vector, and we're going to say that its length is 2. And for the polar form, you need the length of that vector, the magnitude of that vector, and then the direction is the angle. So let's say this angle is 45 degrees. So we say that this vector has polar coordinates 2 and 45 degrees. So we do an angle of 45 degrees from the x-axis and a length of 2. Okay, so this one over here, let's say it has length 3. And let's look at a negative angle here. We're not going to deal with those a whole lot, but they're out there. And negative 120 degrees. So this would be 3, negative 120 degrees. So you put the length first, you put the magnitude first, and then you put the angle second. That's the magnitude and the direction. We could also do this one in a positive direction. We could find that angle there. What would that be? 360 minus 120 is 240. Is that right? So we could also say that this was 3 and a positive 240 degrees. We could do that either way. The rectangular form is more like coordinates. We'll have a vertical movement. Let's say we go over for, it wasn't vertical, that was horizontal. A horizontal movement and a vertical movement. So this vector, we would give coordinates 4, 2. And in the rectangular form, it's going to tell us to go over so many and up or down so many. Left or right so many, up or down so many. Okay? So pretty much like coordinates that we're used to dealing with. Let's say this one, let's say we go to the left, which would be negative 3, and we go up 5. So this vector would have rectangular coordinates negative 3, 5. Now, you've got to look at context to know if you're dealing with just coordinates or you're dealing with a vector. I have seen other notation for vectors where they use little pointy things instead of the parentheses like we use for coordinates, but what I've been looking at the last few days just has the parentheses, so just make sure you're looking at the context. Now, the main thing we want to learn today from this lesson is how to convert from polar to rectangular form. This is where the trig is going to come in. We're going to go from a magnitude and an angle to an x and y coordinate and back. So let's say they give me polar form. They gave me 18 and 120 degrees. That means that I'm looking at a 120 degree angle, which would be right here. And the length of this thing is 18, okay? Now, notice the instructions. It says round to the nearest tenth unless it is a unit circle angle. What we are needing here, what we need is our x and y coordinates, right? We need this. Notice we have the hypotenuse of this right triangle. We need the x and y coordinate. We need this angle here. So we're looking for our reference angle. And our reference angle here would be what? Would be 60 degrees, okay? Now, that's a unit circle angle. That is something that you know how to do without trig, okay? Remember, this would be the 30-degree angle, which means the 30 side, which is over here, is half the hypotenuse. So this would be 9, and then this would be 9 root 3, right? Now, you could do that with trig. The problem is, since it's a unit circle angle and it says to give exact answers, your calculator is not going to give you root 3 here. It's going to give you a decimal for this. So since it's a unit circle angle, you need to recognize your 30-60 triangle, 18, 9, 9 root 3. Now, the other important thing is this 9 is negative, right? Because we're going into the second quadrant, so the x-coordinate is negative. So my rectangular coordinates here are -9 and a positive 9 root 3. So I changed that polar form vector into a rectangular form. Now, this next one is not a unit circle angle. We don't know anything about 33.6 degrees, but we do know it's in the first quadrant. There's my vector, 15.2. This angle is 33.6 degrees, and I need the x-coordinate and the y-coordinate, right? I need this x value, I need this y value. Since they're in the first quadrant, they're both going to be positive. I'm going to use trig for this. So I'm going to say that the sine of 33.6 is opposite over hypotenuse. I'm going to plug that into the calculator. I'm going to multiply, and I get y is about 8.4. Okay, check my calculations there, make sure I did it correctly. Then I'm going to do the same thing with the cosine of 33.6 degrees. That's going to be x over 15.2. Use my calculator, 0.8329. I multiply both sides by 15.2, and I get x is approximately 12.7. So my rectangular coordinates here are my x-coordinate, 12.7, and 8.4. So this says rectangular coordinates, I'd go over 12.7 and up 8.4, and that would also describe this vector. Now, what if they give me the rectangular coordinates and I need to find the polar coordinates? We're going to do basically the same thing. We're going to be working with our trig functions. Notice that we need to be paying attention to see if we get one of our unit circle angles. That's going to be any of your quadrantal angles, your 0, 90, 180, 270. That's going to be 30 degrees, 60 degrees, 45 degrees in any quadrant, okay? So this first one has the coordinates 3, -3. So that puts me where? 3, -3 is a vector in the fourth quadrant, right? So this is 3, this is -3. Now, what should we recognize about this? When our two sides are the same length, right? That's isosceles. That makes it a 45-45. So our reference angle here is 45 degrees. So our hypotenuse, we could use Pythagorean theorem here, but we need an exact answer since it's a unit circle angle. This would be 3 root 2, right? Remember a root 2, okay? So I have my radius. I'm calling it radius because they call it r, but I have the length of that vector. And I have an angle, but it's the reference angle. It's not the actual angle. So what we would do, we would say that the r is 3 root 2, not 3 root 3, 3 root 2. And how far around is it to here? Well, I would do 360 minus 45 degrees, and I'd get 315 degrees, okay? Or I could say that it was -45 degrees, right? I could do either way. We're going to stick with mostly positive, but I want to show you could answer that both ways and still be okay. All right? Now, what about the next one? They give me coordinates of 3, 4. So here's my vector, this is 3, this is 4. Well, the first thing we should recognize, it's a 3, 4, 5 right triangle. You could do Pythagorean theorem, that would be okay. You're going to get 5. So I need to find my angle. It's a first quadrant angle, so I'm not going to have to subtract or anything. I'm going to use my sine ratio or my sine function. The sine of theta is going to be 4 over 5, which is 0.8. I'm going to put that in my calculator, do the inverse sine, and I get 53.1 degrees. So the polar coordinate for this would be 5. That's the length of that vector, and the angle is 53.1 degrees.